So, simplifying rational expressions. A rational expression is in simplified form when the numerator and denominator have no common factors. A lot like simplifying a fraction, right? Simplified fraction, you can't reduce it anymore. How do you reduce? You divide out a common factor from numerator and denominator. So we will be in simplified form when there are no common factors. So steps to simplifying a rational expression, right? So what are we going to do? Every time we do this, what we're going to do. Steps to simplifying rational expressions. Okay, so first thing, number one. Factor the numerator and denominator completely. Okay, good news is they're limited to binomials only. You won't have to do any trinomials. Okay, so then life should be easy because binomials, you know. So first step is to factor everything, right? Second step is to state the restrictions. So the big thing about rational expressions is if there's a variable in the denominator, then there is a restriction, right? Or there may be. We've seen one where there wasn't. When x squared plus 4, okay, there wasn't a restriction. So state the restrictions. And where do you find them? In the denominator. So from the factored form, of the denominator. Okay, so first, factor it, numerator, denominator. Second, look at the factored form of the denominator and state the restrictions, right? So we've gone through the difference. Non-permissible value is when you solve that denominator, set it equal to 0, and you say x equals 3. The restriction would be you say x cannot equal 3. Okay, and it's usually restrictions that we're interested in, right? But we need to know what a non-permissible value is. And third step, there's only 3 steps. Divide out the common factors between the numerator and the denominator. So divide out the common factors. Between the numerator and the denominator. And then step 4, which would be just to check, right? Make sure there are still no common factors, right? Make sure that, oh, they're both even or they're both divisible by 3. I could have reduced it further. So if you didn't get the largest common factor, then there might still be a common factor, okay? So just check it over. Check. Usually that's just quick look. Take a quick look. Yeah, okay, it's good. Simplest. Let's start with the simplest thing, which is simplifying monomial rational expressions. So number 1, simplify monomial. Monomial means one term. I'm going to abbreviate. Monomial rational expressions. Okay? So one term, you will see no plus or minus signs, right? Really, it's just like a fraction, you know, like 14 over 4, 4 over 14, one of the ones we did yesterday. That is a monomial rational expression, right? It's only got one term, top and bottom. So let's take 15x to the 5th over 10x. Now, some of you may have done this, right? If you did 20-0, you're looking at this and going, like, really, you know. So in which case, you can just turn to the homework and do it and then sit and read a book or something, right? This week is really not going to have much for you because in 20-1, you've done this unit, okay? Or the other thing would be help out the people that need some help, right? Some people need some help with this. It'd be nice if you could work with them because, you know, you can point stuff out to them. Okay, so I'm going to do this a little bit differently. What we're going to look for here is the greatest common factor. So what's the biggest number that goes into both 10 and 15?
5. 5x?
Yeah. So, well, 5 is the number, and then x will be the highest power of x. So what we look for is largest number that goes into this, into both, which is 5, and the highest power of x that goes into both, which is actually the lowest power of x. So 5x is the greatest common factor. So we're going to write this as 5x. So how do I get 15? What do I need in here? Need a 3. And how are we going to get x to the 5th if we've got an x out here? X to the 4th. And on the bottom, we're going to do the 5x. And how do we get 10x? 2. Actually, really, if I was placing brackets, I put them in the wrong place. Okay, factored now. What are the restrictions? Here's a big hint. If they're monomials and there's a variable in the denominator, it's just that variable can't be 0, right? Because there's no plus or minus, so there's no fancy term in the bottom, right? It's like 10x or x. So x cannot equal 0. So monomial denominators are really easy. If there's no variable, there is no restriction. If there's a variable, it can't be 0. Okay, we take out the common factors, so we divide out the common factors, right? So that's step 3. So step 1, we factored. Step 2, we did the restriction. Step 3, we take out the common factor. And we're left with 3x to the 4th over 2. Check that. 3 and 2, no common factor. You go next to the 4th, there's no x on the bottom. This is it. Right? That's simplified. It's that simple. Okay, let's kick it up a bit. 25y squared over 40y to the 6th. First step. Okay, greatest common factor. What's the largest number goes into 25 and 40? 5. What's the smallest power of y? Y squared. So our greatest common factor, the one that will divide into both, is 5y squared. So 5y squared, I'll put that in brackets. So now how do I get 25y squared? If I've got 5y squared, what do I multiply that by? By 5, right? Okay, and we've got a 5y squared here. What do we do to get 40? So what do we do to get 40? What number do I put in? 8. What do we do to get y to the 6th? Y to the 4th, right? Because they got to add up. Restriction. Monomial restrictions are easy, right? What is it? Y cannot be 0. Okay. Step 1, factor. Step 2, restriction. Step 3, divide out the common factor. We are left with 5 over 8y to the 4th. Okay. Now remember, what we're saying is these are equivalent, right? We're saying this expression, and if you're going to say it, you got to circle it, and this expression are the same for all values of x except when x is 0. When x is 0, this doesn't evaluate, right? You got a problem because you'll divide by 0. When x is 0 here, you can work this out, and you'll get a value, which is 0. But here, you get undefined, so they're not the same when x is 0, right? This one can be worked out. That one cannot be worked out. Both of these guys doesn't matter. When y is 0, they're both undefined. Okay? But otherwise, they're the same, right? If y is 1, this becomes 25 over 40, which is whatever 25 over 40 reduces, 5 over 8. Right? And when y is 1, this is 5 over 8. Okay? So they're identical. Okay, one more monomial. Negative 12 x to the 4th over negative 3 x to the 5th. Okay, try this one yourself, right? So find the greatest common factor. Then factor the top and factor the bottom. Then state your non-permissible value. Then cancel the factors and be left with the simplified expression. Okay, so try it, then take a look up front. Moving on. Okay, let's simplify with a binomial numerator. And that'll be the only instructions on this, right? I mean, it won't say binomial numerator, that's just what we're doing, but you know, the instructions on the question would be simplify. Okay, that's it. And that just means come up with the simpler form or simplest form. All right, 30x cubed plus 40x squared. Over 25x squared. Okay, restrictions are easy. You can actually state the restriction right now since we're doing a monomial denominator, right? There's only one term, and so it's just if there's a variable there, then we state the restriction, right? But we'll do things in order. So step one is factor. The only thing we can factor is the top. What's the greatest common factor? Or actually, okay, let's be kind of smart about this, right? So the idea here is we want to be able to cancel the greatest common factor between 30, 40, and 25, right? So what number goes into 30, 40, and 25? 5, right? So if we had divided out 10, which we could have, right? So we could have said 10x squared was the common factor, but then on the bottom we don't have a 10 as a factor, right? So we're going to say greatest common factor between these guys is 5, and the lowest power of x all around is x squared, right? So we're going to go 5x squared. So how do I get 30? So how do I get 30? 6. How do I get x cubed? X. Okay, plus, how do I get 40? 8. How do I get x squared? Nothing, right? Just 8. Okay, greatest common factor we've already figured out is 5x squared, right? Okay, and what goes in brackets here? Just 5. Okay, so we're factoring, but we're not just, you know, because normally if I factored this, I would have taken 10x squared out, right? But then that would have left me with this, and I still have a 2 there. So we're going to, you know, be a little smart about this and just say, you know, look, greatest common factor of all these numbers is 5. Let's take the 5 out. Okay, state the restrictions. What can't x be? Okay, so x is not equal to 0. The 5x squareds cancel, right? And we're left with 6x plus 8 over 5. So we're saying for every value of x except what? 0, these two expressions will give you the same answer. Okay? You can plug x as negative 12.7 into both, you'll get the same answer in both. Okay? You can plug x as, you can't plug 0 in, right? Because 0 makes this undefined. Although 0 is fine here, that'll just be 8 over 5, right? So you put a 0 in here, you get a value, here you don't. But we will say these are the same, but there is a restriction, right? Which is that x cannot be 0. Okay, questions? Let's do the next one. Let's do another one. B. 20x cubed minus 12x squared over 16x. Okay, greatest common factor of 20, 12, and 16. 4. Okay, largest number goes in the middle. If you took a 2 out, then that fourth step, right, you'd look again and you'd, oh wait, they're all still even, right? So I could take it. Okay, so we're going to go with 4. What's the highest power of x? Or sorry, what's the lowest power of x, really? Just x, right? So 4x, okay. All right, you fill in the rest. And if you're not writing stuff down, then just fill it in mentally, right? Restriction. For a monomial denominator, it's always that. Unless there's no variable. and then there is no restriction. Okay, simplify. Okay, is that what you got? Okay, let's do a couple more of these. And then we'll hit the binomials in both places and okay, so you're asking yourself, number-wise, what number goes into 14, 10, and 14? 2. And letter-wise, what's the smallest power? Okay, so 2m is it, right? Now, you might want to take a negative 2m out. It depends, right? Let's just do 2m. No, we'll go 2m. Always got to state restrictions, right? Cancel common factors. Now it's at this point that people get a little itchy because they want to cancel the 7m with the 7m. Can you do that? No. Okay. You can only cancel factors, not terms, right? And here, these are factors. Factors are things that multiply together. So these factors are common. They can be canceled. This is not a factored form. It's just a binomial. That's a factor. Okay. You can't cancel into that. Okay, so that's it. We're done, right? One more. 8a plus 22 over 4a. GCF, number. What's the number's greatest common factor? 4 going to 22? 2. How about variable-wise? No variables, right? Because this term, it lacks a variable. Restriction. Cancel common factor, that's what we're left with, right? 4a plus 11 over 2a. Okay. Now if you've done these a different way and like trying, feel free to do them however you like, right? I mean, I'm interested in your simplified answer. I'd like to see a little bit of work, like how did you get it? So, in determine, you got to show work, right? So that means question, some work, answer, and restriction, right? Restriction always has to be there. Okay, let's go on. Last one. Okay, binomial numerator and denominator, and or. So what is this? Number 3. Okay, so this is going to up the ante a little bit. Okay, not for those of you who did 20-1, this is like well below the level you did because they're using a lot of trinomials and a lot of complicated trinomials and rational expressions, so this stuff's going to be, so just help other people out is the big thing, right? Because really, homework-wise, you can look through the whole thing. Okay, just sort of verify that you're doing stuff. Okay, so let's start with this. And I'm giving you one that's in factored form, but that has a little bit of a trick to it. So 3x times 4 minus x over 18 times x minus 4. Okay? So I would say factor that. It pretty much is in factored form though, right? State the non-permissible value. X cannot equal 4, right? Now, all we're looking at is the denominator, right? We don't care about this, although a 4 in here would also give you a 0. Okay, we don't look at numerator. We only look at denominator. Go x is not equal to 4. Really? I saw your marks. Okay, so there's a trick here, right? Do we have a common factor? Is there anything the same top and bottom? Well, the 3 will actually cancel into the 18, right? But I got 4 minus x and x minus 4. They kind of look the same. But I've got a positive 4, and I've got a negative x, and I've got a positive x and a negative 4. So here's what I could do to change one into the other. If I take a negative out of here, so I'm going to go negative 3. The x comes along. Then I'm going to change this because the negative 3 means that I'm going to have to put a negative 4, right? Because I need this to be a positive. This will give me positive 12x. And this will give me negative 3x squared. So I've got negative 3x. If I multiply by x, I get negative 3x squared. Okay? And then I change the 4. So by putting a negative sign out front, I'm changing the sign on what's in the set of brackets, right? So you multiply this out, you get negative 3x squared plus 12x. You multiply this out, you get 12x minus 3x squared. Exact same. Okay? Now we go to the bottom and say, well, I'm going to write the 18 as like 3 times 6 times x minus 4. Okay, common stuff that can be canceled. The 3's, the x minus 4's. We're left with negative x over 6. B, 8x squared, 2x plus 3, and 3x plus 2 times 8x squared. Okay, anything to factor? Denominators are already factored. They're both already factored, right? What are your non-permissible values then? Or sorry, restrictions. We just go with restrictions. Look at the denominator. What can't x be? Can't be 0. Can't be negative 2 over 3. Yeah, negative 2 over 3. Do you know the quick way of doing that? You just change the sign on this, right? Because you imagine what you're doing really is you're saying 3x plus 2 equals 0. So 3x is negative 2. So you're moving this over. That changes its sign. If it was positive, it becomes negative. And then you're dividing by this number, right? So you look at this and you just go change the sign, negative 2 over 3. Okay, so that's the quick way. And then think about it, right? Because if you went 3 times negative 2 over 3, 3's are going to cancel. You get negative 2, which is the opposite of that, and you'll end up with a 0. So that's a way to quickly check it. Okay, do we have any common factors? Anything that cancels? 8x squared. Anything else? No. Right? I mean, kind of look, 2x plus 3, 3x plus 2, I've got all the same numbers and everything, but yeah, they're not the same term. So that's it. Okay, done. Okay, so really, it's 2x plus 3 over 3x plus 2. And what that says is that original expression that I wrote, remember, every time we simplify, we're saying this original expression is identical to, right, is an equivalent rational expression to whatever I come up with the exception that, the restrictions. All right, let's do a few more, like 5 more, and we're done. Let's see, 3x squared minus 15x over 6x minus 30. Actually, almost easier now, right? Because now we actually have to do a little bit of factoring. So, all right, 3, 15, 6, and 30. What goes into all of those? 3, right?
Yeah.
Okay. So 3,
Just 3.
yeah, just 3, right? Because this doesn't have an x. So I could factor this by taking out 3x, right? I could do that and then go x minus 5. So let me show you what I could do. And on the bottom, we would go 6 and then x minus 5. Okay? And actually, this is going to work just fine. Okay? And now we're going to state our non-permissible value, which is x cannot equal 5. Anything else?
0.
No. Where do we look for the non-permissible? Where's the only place we look? Denominator. Okay, so we don't want to look up here. Okay, we will when we do multiplying and dividing, but that's a little bit off, right? But then we have to look in 3 out of 4 places, but we're not there yet. In simplifying, we just look at the denominator. Okay, common factor. So I actually had to take a 3x out, right? If I just taken the 3 out, this would have said x squared minus 5x, would not have had a common denominator. Okay, so you got to look ahead a little bit and just sort of say, yeah, what's my common denominator going to be? And you'll get a feel for it, right? And so what are we left with? Oh, wait, so the 3, that's a 1, that's a 2. Okay, what do we end up with? Up top, 1x1, which is x, and on the bottom, 2. So 3x squared minus 15x over 6x minus 30 is the same as x over 2 for all values of x, except when x is 5. Okay, stop me if you have any questions or if I mess up. X squared plus 16 over 3x plus 12. Okay, first up we're supposed to factor everything, right? Does the top factor? X squared plus 16. No. Okay, so we're going to leave that. Does the bottom factor? Okay, and it's 3 times x plus 4, right? What are our non-permissible value or values? Negative 4, right? So we just look here, we say x, there actually is no value of x that would make this anything other than 16 or bigger. So x can't be negative 4. Anything cancel? No. So it really was pretty close to simplified form, and the only reason we did this was to get the non-permissible values x is negative 4. And that's it, right? So sometimes it really just is what it is. 5x cubed minus x squared over 1 minus 5x. Okay, so up top, x squared, right? I'm going to factor an x squared out of the top. And we get 5x minus 1. We look at the bottom and we say, that kind of looks like 5x minus 1, except it's reversed, so how can I make it 5x minus 1? Put a negative sign in front, and then write 5x minus 1. Okay, so that's the factoring we're going to do on this one, right? We factored the top, we say, hey, I want to be able to cancel these things, I've got to change this a little bit. Now non-permissible value. So what can't it be? Change the sign on this. 1, divide by this, 5. So can't be 1/5. Try that. Go here. You put a 1/5 in here, you'll get 1 minus 1. 0. Okay, can't have that. Okay, crosses off. Did it? Did it? When these cross off, they become 1s, right? They don't just sort of disappear. So on the bottom, we really have negative 1. X squared over negative 1 is really what? How am I going to write that? Negative x squared, right? Yeah, we're not going to put a negative 1 on the bottom. We'll just say it's a negative. You've got x squared divided by negative 1 is negative x squared. Okay? 2 more, maybe 3. 2 or 3 more. X squared minus 25 over 4x plus 20. 2 more. Okay, here's the only binomial that actually factors to be the product of two binomials, right? So all you're ever going to have to do in rational expression is binomials, right? Two terms. You're never going to see x squared plus 7x plus 12 or anything like that, right? That has to factor it. Okay? But this is the one binomial. It's called a difference of squares. Okay? Do you remember how this factors? It's two binomials. Okay, well, to get an x squared, we got to lead with an x, right? Plus 5 and minus 5. Yeah. Okay, so this difference of squares, okay, factors by taking the square root of the first term, which is the x, plus the square root of the second, which is 5, square root of the first term, and then minus. When you go to FOIL this out, remember FOIL, you get x squared minus 5x plus 5x, so that middle term, the x's disappear, minus 25. Factor the bottom. How do we factor that? Okay, take out a 4, right? Because we're going to be left with an x plus 5, which we're then going to cancel, but not before we do what? State the restriction, which is? Negative 5, right? So the non-permissible value is that x equals negative 5. The restriction is that x cannot equal, right? And generally we state restrictions. So anytime you do rational expression question, you know, simplifying, factor it, state the restrictions, right, and then cancel. And you have to state the restrictions because otherwise this goes away, and this expression here has no restrictions. Right? No restriction on x minus 5 over 4. Right? And again, what are we saying? For any value of x, these two are equivalent. But it's a lot easier to do this than it is to do that. Okay? And that's why we simplify rational expressions. All right, good enough. I think that's enough.